right, today we want to look at the laws and properties of indices. But before then, let us look at some basic concepts about indices. Now, if you have a variable, let's say A, carrying another variable, let's say X, this X, we can call it power, all right? We can also call it index, and we can also call it exponent. We can call it exponent. Now, the variable that is carrying the exponent or the power or the index, we call it base. We call it base. So example is we can say 3 exponent x. We can say 2 raised to the power 4. We can say 5 index 6. All right. And the plural form of index is called indices. All right, as we can have on the board. Now let us look at the laws of indices. Before anybody can solve questions under indices, we need to learn our laws and the properties. So let us look at our first law called product law. Product law, which states that if you have a base raised to the power, let's say x, times the same base raised to the power y is the same as the base raised to the power summation of the exponent, as we can have. So if the bases are the same and they are multiplying, we pick the base, then we add the exponent, as we can see. Let us look at some example under this. If I have 3 raised to the power x times 3 raised to the power y is the same as 3 raised to the power x plus y. All right. Another example that we can have, if I have 2 raised to the power 2 times 2 raised to the power 3 is the same as 2 raised to the power 2 plus 3 from the law that we studied. And that will give us 2 raised to the power 5, which will give us 32. All right. Now let us also look at another example. If I have x raised to the power 2, y raised to the power 3 times x, y raised to the power, let's say 2. Now how do we multiply this? The x raised to the power 2 will multiply the x. And in indices, anytime we see a whole number without any exponent, it means it's carrying an exponent 1. So it's going to be x raised to the power 2 plus 1. Then our y raised to the power 3 plus 2, which is going to give us x raised to the power 3, y raised to the power 5. So we can have these few examples under the product law. Now let us look at the second law called the quotient law, all right, of indices, which talks about division. If I have a raised to the power x over a raised to the power y is equivalent to a raised to the power x divided by a raised to the power y. When the bases are the same and they are dividing, is the same as our base raised to the power x minus y. So division moves with subtraction, multiplication moves with addition. Let us look at some examples here. Let's say I have 2 raised to the power 4 divided by 2 raised to the power 2. According to the law, it will be the same as 2 raised to the power 4 minus 2, which will give me 2 raised to the power 2, and that will give me 4. I have 10 raised to the power x divided by 10 raised to the power y. All right. I'm going to have 10 raised to the power x minus y, according to the law. Again, If I have, let's say, x raised to the power 6 over x raised to the power 5 is the same as x raised to the power 6 divided by x raised to the power 5, which will give me x raised to the power 6 minus 5. And that will give me x raised to the power 1, which will be x. So these are a few examples that we can have under the quotient law. Now let us move to what we call the power law, right? The power law of indices. Now it's simple. If I have a raised to the power n or raised to the power n, how do I expand this? This power will come and multiply this power to power. So I have a raised to the power mn. All right. Another example. If I have a raised to the power y or raised to the power 2, is the same as a. These two will multiply the y, and I'm going to have 2y. Another example. If I have, let's say, a raised to the power 2, b raised to the power 3, or power 2, power to power. So in this case, this will multiply this, and I'm going to have a raised to the power 4. This will multiply this, b raised to the power 6, as we call it, power to power. If I have, let's say, 2 raised to the power 3 or power 2, is the same as 2 raised to the power, this will multiply this, 6. And when we do this, we can get 64. So these are some few laws of indices that we can have. Let us move on to the properties of indices. All right, let us look at our first property of indices. If I have a raised to the power 0 is equal to 1. If I have, let's say, 100 raised to the power 0 is equal to 1. So in indices, any non-zero number raised to the power 0 is going to give us what? 1. So this is the first property that we can have. Let us look at the second property. Let's say I have a base raised to the power negative exponent. Is the same as 1 over the base raised to the power the positive exponent, as we can see here. An example is this. I have, let's say, 3 raised to the power negative 2. Is the same as 1 over 3 raised to the power 2, which we can break it as 1 over 9. All right. Let's say I have 4 raised to the power minus half. Is the same as 1 over 4 raised to the power half, which we can further simplify this. But as we move ahead, we'll see how we can simplify them. Now, another example is if we have, let's say, 16 raised to the power negative 1. It's the same as 1 over 16 raised to the power 1, which will give us 1 over 16. So we can have these examples. Let us look at property 3. Now, if I have a over b all raised to the power n, we can expand this as a raised to the power n all over b raised to the power n. So an example is that if I have 2 over 3 raised to the power 2, how do I simplify this? It will be 2 raised to the power 2 over 3 raised to the power 2, which is going to give me 4 over 9. Let us look at our fourth property. Now, if I have a over b all raised to the power negative exponent, first of all, we need to get rid of our negative. So how do we get rid of it? We are going to reciprocate the one in the bracket. So we have b over a, all right, all raised to the power n. Then we get rid of the negative. The next procedure is we remove our bracket. So our b will raise to the power n and a will raise to the power n. So this will affect this, this will affect that. An example is that I can have 2 over 3 all raised to the power negative 2. According to the property, I have to get rid of this negative. So that will be 3 over 2 all raised to the power 2. Then I have to get rid of the bracket. And that will be 3 raised to the power 2 over 2 raised to the power 2. And that will give me 9 over 4. Let us move to the fifth one. If I have a raised to the power 1 over 2, which is a fraction, 1 over 2 in indices is the same as square root. So it's going to be square root of a. If I have a raised to the power 1 over 3 in indices, 1 over 3 is the same as cube root. So it will be cube root of a. If I have a raised to the power 1 over 4, is the same as fourth root, all right, of a. Now, let us look at another one here. Let's say I have a raised to the power 3 over 2. This is the same as square root. We change the 2 here, which is the denominator. If it's 2, you make it square root. So square root of a all raised to the power, our numerator, which is 3. Again, if I have a raised to the power, let's say 2 over 3, because the base here, or because the denominator of the fraction is 3, you make it cube root. So it will be cube root of a all raised to the power, our numerator. And it can move on. We can have a raised to the power, let's say 5 over 4. So we can have fourth root of a all raised to the power 5. So these are some few basic properties of indices. Now let us look at how we can use these properties and laws to try these questions. So these are some try questions that we can have here. Students should try it and put the answers in the comment section. Watch out for more examinable calculations under this topic. Thank you.